Hi, thank you for having us at this great event. My name is Trisha Andrew. I'm a professor of chemistry and chemical engineering, and here I'm actually present as a co-founder of Soliyarn. We are a textiles company that uses a mixture of microelectronics fabrication technology that I developed in my academic lab, and a lot of textiles experience from our business admin team in order to make wash stable, reliable, high quality electronics on textiles. So next slide, please. Thank you. So this is a overview of some of the devices, individual devices that we have been able to actually demonstrate on fabrics. Some of the key features that we focus on in our company is basically the ability to start with directly off the shelf fibers, fabrics, and garments pre-made with any number of finishes or raw. Effectively, the kind of chemistry that we do is a chemical vapor deposition process that is surface agnostic. And so that allows us to monolithically grow a lot of nanostructured devices directly from the surface of either a fiber, a yarn, or a pre-made textile or garment. And so we basically are able to grow a lot of variety of energy harvesting, energy storage, and also sensor-based devices directly on these fabrics themselves. Next slide, please. And when we started the company, my co-founder, Adrian Beach, who's also on the call, and I basically were looking at this from two very different points of view. AJ from very long history of working in industrial R&D teams, leading them, pardon me, and then myself as an academic who had gotten into the area of wearable electronics in the early 2010s. And we saw that some of the things that people were proposing, not only in the academic realm, but also in industry, in startups, and also advanced companies, was largely to use deposition techniques and fabrication methods that have either been around for a long time in the kind of dumb textiles or dyeing markets, if you will, and also in microelectronics fabrication in terms of just putting down doctor bladed coatings to make these kinds of wearable electronics on textiles. And it turns out that it just doesn't work out because a lot of those pre-existing technologies just give you devices that either are not as high quality as the ones that you would put out on a flat, rigid substrate like glass or plastic, or on the other hand, would give you fabrics or garments that basically feel like plastic wrap. And so you wouldn't really want to wear them. And so there's always been this trade-off between quality and accuracy of the device or power metrics and comfort, breathability, and something that someone would actually want to wear. There's another pernicious thing that really kind of came into my consciousness actually much later, and that's the environmental impact of all of these manufacturing technologies. When you think about the volume throughput of just garments, fast fashion or not, it is a very, very large number. It's over 3 orders of magnitude larger than the amount of microelectronics chips that are even made. And so this environmental impact, when we're thinking about a new kind of technology like smart textiles, becomes really important. Next slide, please. So what basically our company is commercializing is a series of deposition techniques that my lab had perfected, again, starting in about 2012. And the idea at the time as an academic, I had the freedom to kind of play around with a crazy idea, which was to ask whether I could use chemical vapor deposition in order to make polymer coatings. And the short answer is yes. And so we kind of perfected this in the academic realm, and Soliyarn is now commercializing this technology as a way of a very broad and generalizable way to effectively add a conformal coating of some kind of functional polymer directly on, again, pre-made yarns, fibers, or fabrics. And the function, the specific function of that polymer coating can be selected depending on the end application. And so we actually have a suite of different chemistries and monomers that we use that span the areas of conductive coatings in order to make bus lines, interconnects, electrodes for health monitors, and also active heated garments, all the way to protective kinds of coatings that effectively act as hydrophobic barriers or just protective layers for electronic components, or in the least fire retardant coatings for, again, a lot of electronics. And other functional textiles that we work with, and sweat and dirt and soil proof kinds of fabrics. The general process is shown here. So we take our pre-made fabric fiber, our garment, put it in our reactor that is designed in-house at Soliyarn. We have two versions that I'll talk about. And then there's basically a rinse step that can be skipped. And then we have the final product completely done. All of these processes are solvent-free except for that optional rinse step. And so we drastically reduce the amount of solvent that's actually used during this process. Next slide, please. The advantage of using chemical vapor deposition is that if you zoom down into the nano and micro scale, you actually get a completely conformal film. These are scanning electron microscope images of pineapple fiber fabric and cotton. You can see the yarn structure, the very disordered yarn structure on the left. These are actually SEMs of the coating on that yarn structure. You cannot actually distinguish the coating from the structure of the fabric, and that's because you get this entirely conformal coat of the functional polymer, no matter what kind of structure you're using, directly on the fabric itself. And the same applies again to our protective coatings. Here, the main advantage is that we can actually put down nanoscale thicknesses of the polymers, 500 nanometers all the way up to a couple microns. And that actually allows you to preserve, say, the underlying properties of not only substrate, but an underlying coating that you, for example, put the encapsulation on top of. And so, for instance, we could take metallized fabrics and put a nanoscale coating down about 500 nanometers and still maintain the surface conductivity of the silver, which you cannot absolutely do with any other kind of protective layers that you could put down. Next slide, please.
We're just gonna have to wrap this up just real quickly.
Sure. These are just some examples of some of the technologies that we've made on the conductive on the right, and the waterproofing GIF repeating. You could show how we could actually pattern the waterproof coating, and so we could allow for sweat ejection, for instance, when we have a conductive fabric for heated garments, for instance. So we could not only protect our active heating elements, but we could eject the sweat actively away from the electronics, so that we don't mess up or short circuit someone who's wearing this. Can you keep going forward? I'll just, yep, one more. Let's just end with a team slide here, especially since a lot of folks had the emphasis on our team here. So this shows our entire company team at this time, but also our two founders, myself on the right and AJ Beach, who's also on this call. As I said, we actually do span, I'm obviously a professor of chemistry and chemical engineering. AJ is our business guy, but it seems kind of a reductive title. And Shai, who's also on the call, is our chief operating officer. Both AJ and Shai actually have experience in leading a lot of tech research teams, and Shai in particular has had previous experience working in the textiles industry as a buyer and also as a sourcer, and she understands very, very well both how easy it is to get textiles and also how hard it is to get the right kind of textile for a particular application, and the importance of using the right kind of deposition method in order to actually make a final product. And we have a really great rounded out team of R&D engineers shown on the bottom, who span in expertise from materials engineers to process and reactor design to mechanical engineers and electrical engineering, to actually allow us to accomplish a lot of different wide applications, all the way from simple waterproofing up to a completed and encapsulated electronic system directly on a fabric with sweat channeling. So I'm happy to answer questions, and I'm sure Shai and AJ will pipe up as well as needed.
Awesome. Thank you so much. We're running a little short on time for the Q&A, so we're just going to do 2 questions from the panel.
Just a quick question here. Have you, number one, great presentation and fascinating technology. Have you thought about using this in pandemic supply, any chance? Because I came across multiple approaches to another new technology that's applied to a pandemic world. So for example, silver and like a bamboo are one of the 2 materials I've heard that works against the virus. So I was wondering about that.
Yes, we certainly have an antiviral coating that we have demonstrated viral the word is escaping me. We could disassemble viral capsids with our antiviral coating. The advantage, once again, of using chemical vapor deposition is that the coating is reusable and washable. And so unlike melt blown masks, like the standard N95, you don't actually lose the pore structure. You don't use a kind of physical pore structure to cause the kind of bacterial filtration. So we have shown that.
Sure. One more question. Do you have a question?
Yeah. So I can go. Two things I would like to, sort of understand a bit more, but you don't have to answer it in this call. So one is, I mean, you've talked a lot about tech, but you all never talked about the cost of delivering this. So maybe you should actually mention that in terms of, is it really like what cost is the cost of commercial production of this? Is this really like minuscule, 2x, 3x? So what is that delivery? Second, I think from a commercialization aspect, I think most VCs touch this. I think you are all, like most people are coming from a university system. How are you thinking about early design partners? Have you actually taken it to a few early customers? You're not going to, are you taking it to fabric manufacturers? Which of those are you in early conversations with? Have they had a look at this product? And what are the early use cases for some of them? I think all of that, I think if you're thought through and maybe present that as part of your go-to-market plan, that would be useful.
I don't believe I have time to answer that question, but I would basically redirect that to Shai and AJ, and we've addressed everything that you're asking, and that information was in part of the slide deck. I just didn't have time to get to it. So.
Yeah, I can take that quickly. You're talking about COGS. It's pennies on the dollars. What we do know in the waterproofing side, we've been talking with a relatively large mill that's based in North Carolina. The cost for our production is in line with what they need for profits. Early customers, we do have a customer. Their name is ADS. They're the #1 supplier to the military as a small business, so under 500 employees. They did $3.5 billion in sales last year. They've already pre-purchased a roll of fabric from us for conductive fabric. And they see a huge amount of demand. There's lots of other stories that I could tell you about as far as early customers and partnerships, but for the sake of efficiency, that kind of hits the high points, I think.
Perfect.